Okay, so this is just a reminder that these problems will not be exactly the ones that you get, but they will be really close. All right, so this video is going to go from questions 6 through 17. I had originally said not to do questions 10 and 11, but I took those out, so we are doing questions 10 and 11 here. You will need to have the full assignment completed Monday. Or if you're watching this video in the future, maybe it's a different day. All right, so I'm going to mark up this page. A student ran out of time on a multiple choice exam and randomly guessed the answer to 2 problems. So I have 2 different problems that I'm going to find an answer to. So answer 1 and answer 2. Each problem had 4 choices. So I have 4 options for each problem. And there's only one correct answer. So one answer is correct in both cases. What is the probability that she answered neither of the problems correctly? So if I don't want to get them correct, so this is that I get them correct, then it's going to be the opposite. So that means that I have 3 answers that are not correct on both problems. I want to get them both wrong, so I want to get the first question and the second question wrong. Because I use that word and, I'm going to multiply. 3 times 3 is 9. 4 times 4 is 16. And that does not simplify. So that would be your final answer. Question number 7. All right, a card question. Suppose a card is drawn at random and then shuffled back into the deck. So it's shuffled back into the deck. That's important. And then a second card is drawn at random. What is the probability of the first being a spade, then a red, then an 8? So I'm drawing 3 cards here. So spade are right here. And that is, there are 4 different kinds of cards, so it is 1/4 of my deck. You could also write this as 13 out of 52, and then simplify that from there. My next thing that I want is a red card. My red is here. There are 2 different colors. So that would be half of my deck. You could also write it as 26 out of 52, which simplifies to be 1/2. And then the last one that I want is that 8. I'm actually going to write that out because I don't want it to get lost with our other numbers. Oops, I didn't click the pen. So my 8s are right here. There are 4 out of the 52, which simplifies to be 1/13. I have that special word in here that we want to pay attention to, and that is and. So I want to have my first card as a spade, and then the red card. And whenever I use the word and, remember that means to multiply. We're going to multiply straight across. 1 times 1 is 1 times 1 is 1. And then 4 times 2 is 8 times 13 is going to be 104. This asks us for a decimal place, rounding to 4 decimals. So I'm going to do 1 divided by 104. And that gives me 0.009615. It asks me to round that to 4 decimal places, which would be 1, 2, 3, 4. The number following is a 1, so my answer would be 0.0096. It's a 1 there, which means that I'm going to leave that 6 alone. If it was a 5 or greater, I would have rounded that 6 up. Number 8. A radio disc jockey has 8 songs on this upcoming hour's playlist. 3 are rock, 3 are reggae, 2 are country. So I have 3 rock, 3 reggae, 2 country, for a total of 8 songs. The disc jockey randomly chooses the first song to play and then randomly chooses the second song to play from the remaining songs. What is the probability that both are country? So my first pick, I have 8 songs to choose from and I want it to be country. So there are 2 options that are country. My second song, I've already picked one of the songs from the playlist. So now there are only 7 songs left. We're going to assume the first one was country, which means that there are only 2 country songs left to pick from. So there's only one of the 2 left to pick from. So I'm going to multiply these together because I wanted both songs, meaning that I'm doing the first and the second song. Multiply those together, straight across. 2 times 1 is 2. 8 times 7, is 56. I can simplify that to 1 out of 28. And that would be my final answer. Again, your questions aren't going to be exactly the same, but they're going to be the same process. So use this to help you with your question. Same ideas, just a little bit different, maybe number-wise, or your word problem might be a little different, but it's still going to be the same exact process. Number 9. Okay, so from this one, it's not put back into the deck. So this one's going to be a little different. So it says here that it is not put back in the deck. So I'm going to use that 52 this time as my denominator because remember there's 52 cards in a standard deck. So I want 3 draws and all of them to be spades. So spade 1, there are spades right here. So there are 13 spades out of the 52 cards. Then spade number 2, I already chose a spade in that first draw. So now there's 12 spades left and I drew a card and I kept it. So there's only 51 cards. And then spade number 3. Again, I drew a spade from the first 2 draws. So now there's only 11 spades left. And there's 50 cards in the deck because I kept those first 2 draws. You're going to multiply those together because I'm doing an and probability that all 3 are spades. So the first and the second and the third. I'm going to have 13 times 12 times 11. It's going to give me 1,716. Didn't know if I'd have enough space there to write it. I did. And then we're going to have 52 times 51 times 50 to get 132,600. This is asking for it as a decimal in 4 decimal places. So I'm going to do 1716 divided by 132,600 to get 0.01294. Asked me for 4 decimal places. The number after the 9 is a 4, so I do not need to round up. So it's just going to be 0.001. 0.0129. So that would be my answer here. Again, your numbers might be different, but it will be the same concept. Number 10. Okay, number 10, we are asked here about, there are 2 parts to this. I'm going to scroll right there. Okay, so I want the probabilities. Remember, the P here in the beginning, choose a pen. P here in the beginning means that I need a probability. So I am first asked for A, and it says that A is the chess club, B is the science club. So A is chess, B is science. I think that's the case in all of your problems, that the first one on the left, the circle on the left is A, circle on the right is B. So probability of A, that is going to be the entire circle. So I want everything in the whole circle. I have 1, 2, 3, 4 names there. So I'm going to have 4 out of the 11 students and that can't be simplified, so I'm going to leave it. B is everybody in the entire circle, just like the last time. So I have 1, 2, 3, 4, 5, 6 students in this case. So I have 6 out of 11. Remember to simplify if possible. These ones can't be. A and B is where they intersect. So I'm going to erase that so we can see our names here a little bit. Our intersect is where the 2 overlap. And there is 1 there out of the 11 students. The next one is B given A. So that means that I am given circle A and just circle A. So I'm only paying attention to this circle right here. And then, so given circle A, how many students are in B? So I only had 1, 2, 3, 4 students in the entire circle A. So my denominator is 4 because that's what I was given. There were 4 students in A. And in circle A, only 1 of them was from the group B. This next problem asks for the probability of A times something. So I have 4 over 11 for the probability of A times the probability of what we just found, which was 1/4. 4 times 1 is 4. 11 times 4 is 44. We simplify that and we get 1 out of 11. So then the next one says which is the same to the probability of A and B, which was 1/11. The only other place we see 1/11 was where we multiplied those together, so our answer would be that multiplied. Again, your problem will look just a hair different, but it's still the same general concept. I'm just explaining to you your problem with different names. You might get lucky and they might be the same, but for the most part, they will probably be different. All right, number 11. A trial drug had 690 participants. A survey was taken to determine how many had anxiety as a side effect, how many had nausea, how many had dizziness. The Venn diagram below shows the results. Each number gives the number of participants who fell in that diagram category. So the first one is how many students or participants had anxiety. So I'm looking at this circle right here, and I'm going to add those numbers together. So I'm going to have 36 plus 23 plus 126 plus 86, because everybody in the circle had anxiety as one of their symptoms. So add those together and we get 271. The next one, how many other participants had neither anxiety nor dizziness? So I am wanting just these people, because these people, let me use a highlighter, these people right here, because these people had a symptom, but it was not anxiety or dizziness. And I want these people out here because, again, they did not experience anxiety or dizziness. So I'm adding 62 plus 105, because those are all the people who did not experience anxiety or dizziness. 62 plus 105 is going to give us 167. Our last one is the participants who had both nausea and dizziness but didn't have anxiety. So I'm going to erase this. And I don't want to include any of my dizzy people. So I'm going to grab this, and I don't want to include any of the numbers from my dizzy circle, but I want the participants who had both nausea and dizziness, not anxiety. So those people would be right here, so 23. Your problem might look a little different. Same, I didn't want to do that. We just wanted to move on. Okay, number 12. All right, so in an aquarium, there are 7 large fish and 6 small fish. So I had 7 large, 6 small, and of those 6 small, half of them were red. So 3 red, 3 not red. One fish is selected at random. Find the probability that it is a small red fish. So I have a total of 13 fish. And then I want it to be small and red. So 3 out of those 13 fish are your small and red fish. Again, make sure that you're putting them in a simplified fractions. So I'm going to put it in 3 out of 13. You can check it. It will tell you if you're right or not. All right. Yeah, let's go through this one. Markup. I know that the card ones are definitely not everybody's best friend. All right, so probability that we get a face card. So here are our face cards. There are 12 out of 52. We can simplify that. Half of 12 is 6. Half of 52 is 26. We can keep going. And 13. All right, so the next one, what is the probability that the card drawn is black? Our black are right here. We've talked about this, that is half of our deck. And then the probability that we get a face card or a black card. So we know that there are 26 black cards right here. But I did not include these face cards, which there are 6 of. 6. So I'm going to add those together. 26 plus 6 is going to give us 32 out of the 52 cards. Simplify that. Half of 32 is 16. Half of 32 is 16. Half of 52 is 26. They're very similar. I got myself confused. Half of 16 is 8, and half of 26 is 13. So that would be our simplified fraction, and that would be then our answer for that. You could have done this a different way. That is the way I prefer to do it. I think it's the most visual way to do it if you're a visual person. If you don't understand it this way, I can definitely show you a different way as well. 14. Markup. Okay. So this one is another one very similar to our last one that we talked about with some Venn diagrams. So finding probability still, and I'm going to change my pen to black here. So the probability of, this is our A circle and our B circle. A here is this whole circle, and we had 14 students. So I have 1, 2, 3, 4, 5, 6, 7 out of the 14, which is 1/2. Our B circle is the other circle here. We have 1, 2, 3, 4, 5, 6, 7, 8 in that circle. Oops, 8 out of the 14. That simplifies to be 4 out of 7. Next one is A and B, which is the middle here. And that is 2 out of our 14, which simplifies to be 1/7. A or B, which would be everybody in our circles. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So this one asks for the probability of A, which is 1/2, plus the probability of B, which is 4 out of 7. Then minus the probability of A and B, which is 1 out of 7. We need common denominators, so if you would like, you can just throw this one into Desmos. Our common denominator here is going to be 14, so I would have 7 out of 14 plus 8 out of 14 minus 2 out of 14. 14 would stay. 7 plus 8 is going to be 15 minus 2 is 13. So that would be my answer. Again, you can just type this into Desmos. You don't have to change don't need to do this step. Not needed with Desmos. Desmos would just jump you to that answer, which is fine. So I'm asked, what is, come on, that equal to? So where else do I see 13 out of 14? And I see that right there with A or B. So my answer for that question would be that choice there. Yours will look very similar to this. All right, number 15, bit of a long one, not as long as you think it is. You've seen something similar to this before. All right, so an 8-sided die with faces labeled 1 through 8 is rolled once. We're going to find some probabilities. So rolling a number greater than 2, 3, 4, 5, 6, 7, and 8. So I checked 1, 2, 3, 4, 5, 6 out of my 8 options. Simplify that down to 3 out of 4. I put that 4 in the wrong spot. So that would simplify to 3 over 4. Oops, not what I wanted to do. Get rid of that line. Okay. Rolling an even number, 2, 4, 6, and 8, which is 4 out of my 8 options. Simplify that down to 1/2. Rolling a number greater than 2 or rolling an even number. So greater than 2 would be 3, 4, 5, 6, 7, 8. Or an even number, I can also add 2 to that. So that is 7 out of my 8 choices. Rolling a number greater than 2 and even. So my numbers greater than 2 are these, but it also has to be even. So I cannot include 7 or, nope, I can include 4. That was a really sloppy X. Let me redo that one. So I can include 4, but I cannot include 3. And I cannot include 5. So that would be 3 out of my 8 choices. So I need to then compute the following. Event A, which was this one here. So 3 over 4 plus event B, which is 1/2, minus A and B, which is that one, 3 over 8. You'll need some common denominators here again, so it is going to be 6 out of 8 minus 4 out of 8. Again, you can just throw this into Desmos. I just don't have it pulled up, so I'm not. And then minus 3 out of 8. 6 plus 4 is 10 minus 3 gives us total of 7 out of 8, and then we are asked where we see that again. So I'm looking for where else I get that 7 over 8, and then I get that 7 over 8 right here with A or B. Would be your answer there. 16. All right, Fran the Fearless has a well-known act at the local zoo. As part of the act, Fran handles scary animals that she picks out at random from a box of terror. The following animals are in the box. So we have 19 snakes that are poisonous. I have 6 snakes that are non-poisonous. Underline those. 9 spiders that are poisonous, and 7 spiders that are non-poisonous. What is the probability that I get a non-poisonous or a spider? So I have how many total animals? I'm going to add those together to find that. So I have 19, 6, 9, and 7. So I have 41 animals. Add those together. So my denominator will be 41, and I want a non-poisonous or a spider. So my non-poisonous options are these ones, or a spider. So my other spiders option is that there. So I'm going to add those together. 6 plus 9 plus 7, and that is 22. I don't want that. There we go. And that I can think of, we can't simplify that, but it's asking for the nearest hundredth anyways, so I'm going to do 22 divided by 41, and that gives me 0.5365. This is the 10th, this is the 100th, the number after it is greater than 5, so I need to round up, so I'd have 0.54. That would be my final answer. And last one. And markup. So, at a certain fast food restaurant, I have 53% of the customers who order a chicken sandwich, 41% of customers who order french fries, and 22% of customers who order both a chicken sandwich and french fries. What is the probability that a randomly selected customer will order a chicken sandwich or french fries or both? So the way that this is going to work is going to be easiest if we draw a Venn diagram. So this is my chicken sandwich. These are my fries. I was told that 22% of the customers order both. So 22% of my customers live here. 53% of the customers are going to be in this circle of chicken sandwiches, and 41% of my customers live in the fries. If I was to just add all of these numbers together, if I did 53% plus 22% plus 41%, that's going to give me 116%. And we know that our probability cannot be greater than 100. That's just not how probability works, because you can't have a greater chance of something happening than it just happening. So the way that I'm going to figure this out, since I know 22% are both, I'm going to do 53% of my chicken people minus the 22% who also get fries, so 31% of my people just order chicken sandwiches. And I can do the same thing with my fries. 41 minus 22, that means 19% just order fries. 22% order both. Of that 53% minus the 22% who also get the fries, so 31% just get chicken sandwiches. Now I can add these together, so 31% plus 22% plus 19% gives me 72% of people, not just students, who order one of the items or both of them. This asks for it as a decimal, not as a percentage, so we're going to divide that by 100, and you're going to get 0.72. So that would be my answer for this problem. You would want to do something extremely similar, but your numbers will likely be different. All right, make sure that you watch your question number before trying to ask me a question, because that saves me from answering the same question 72 times, but it also will hopefully help you before I am actually able to get to you, since there's not just you in the class.